trig functions of any angle, which means we need to find angles. It's exciting. So what I want to remind you guys of is quadrants. When we start going through the quadrants, remember you are plus plus, minus plus, minus minus, and plus minus. We remember that, right? Those are the signs of your ordered pairs and so on. So what we're going to look at is how do you place an angle given an ordered pair and then find all of the trig functions via that placement. Okay? For example, if I take something where I say, hey, let's look at, I think I have one on my slide here.
Sorry, can I ask a really quick question?
Yeah.
About like the drawing the angles in radian form, can you, if it's given to you in radian form and you need to like find a positive and negative coterminal, does it need to, the answers need to be in radian form too?
Yeah. If you're given
can
radian,
you convert it?
No, I don't want you to convert it. You were gone for a few days. You'll have to trust me that counting and placing things in radian form is actually pretty quick.
Do you just subtract and add like 2 pi?
It's actually easier to go into and draw the picture, draw it first, and then use what's called a reference angle to see where it winds up. It's very, very easy to do. You have to trust me on this one. I know it's been a while, and
because I just like converted it and then.
You don't want to. You'll have to believe me that you don't want to do that because it takes too long. And it's much easier to be grading.
It's less confusing and when it's just one number.
I know, but you have to trust me that we'll get you through it. Okay. So, for example, I want to look at, let's say, -3 and 4, and I want to write out where this is, and then figure out the trig functions off of it. So, -3 and 4 puts you into the second quadrant. Right there. And it creates a right triangle, which puts your radius, or I'm sorry, puts your hypotenuse where?
5.
5. Okay. So obviously I threw in one real quick here with 3, 4, 5. You can see a lot of triples and things like that. But what I wanted to do is get you guys the idea of how things are going to get placed with the idea that we're going to go through all 6 trig functions within these ordered pairs. As we get through these ordered pair pieces, you'll start to see why certain things are happening with your special right triangles. It's kind of the whole point of where we're heading towards. So let me put my notes at the same time. Let's through it. So here's what we got. If we want to place theta to be any angle where your initial side is always at 0, your terminal side spins into one of the quadrants, and the value of theta is that angle. Remember, as it comes up and over. This is going to be our ordered pair, just like we did a second ago, that 3, 4, or -3 and 4. And what we're going to do is, instead of calling it the hypotenuse, we're going to call it a radius. Because as we place this stuff eventually into our circle, what we're going to call the unit circle, the radius doesn't change going around the circle. It won't change, except for that one. That's really bad. So. Okay. So what I want to look at is we have sine, cosine, tangent, and the reciprocal functions. So when we have sine, sine of theta is y over r. Cosine, x over r. Tangent is y over x. Cosecant, just flip it. Secant and cotangent. And there's reasons for these ordered pairs why this is happening. Okay. So when I go back to that idea from the second ago where I had that value of -3 and 4, if I put that back to here, actually, don't worry about this stuff. That initial side of theta came over and around, and it made this would have been an obtuse angle. Okay. Theta comes up and around. What we do is we work. Oops. This becomes 5. We work with what's called the reference angle. Remember, the reference angle is the value, how far it's bounced off of the x-axis. Okay. So in this case, if, let's say we had 150 degrees for theta, that means your reference angle, you are 30 degrees up from the x-axis. If it was 210, you were 30 degrees below it. You were 330, you're 30 degrees below 360. That reference is how far you're going to be off of something. So what happens then is that if you place yourself as that reference angle, trig functions are nothing more than, so it's just SOHCAHTOA. If you look, don't you always look at your opposite? Your opposite's 4, your hypotenuse is 5, so the sine of that angle is 4/5. That's what you're looking at. You're creating SOHCAHTOA via ordered pairs. Okay? You're creating SOHCAHTOA from ordered pairs, which is going to eventually lead us to being able to see when we get to our special right triangles, the cosine and sine values are the ordered pairs. So, if I want to go through an example, let's see which one was it. We did this already, we know that. Oh, I did 4, -3, so we'll do this. We'll do this one. Let's write them all out with 3, -4. The 6 trig functions, which means we have to figure out what the radius is. Well, when I draw this in, come back, I have 3, -4, and then this is going to be at 5. It's just a matter of listing it out. When we spin this around, the theta value would come all the way around to the 4th quadrant. What we do is we work with the angle on the inside of that.
Then we do 360 minus that.
Yes, for this case, that's how you get the reference angle for this one. We're not actually trying to find the specific angle. We're just writing it out in terms of the side lengths for right now. Okay. Because what's happened is that as you get into the reference angle is going to allow you to move throughout the quadrants. Because the reference angle won't change. The signs, the SIGN of the ordered pairs is what changes as you move throughout the quadrants. Okay. So in this case, if I place theta there, which is where it should be, because it's a reference, it's how far it's off the x-axis, the sine is opposite over hypotenuse, so that's -4/5. Pretty quick, right? Cosine, 3/5. Tangent, -4/3. And that's your stuff. From that, what do you have to do to get your reciprocals? Just flip them. All we have to do is just flip them. So, let me move this over just a little bit. So cosecant, -5/4, secant, 5/3, and cotangent, -3/4. Will you see simplified radical form in a lot of these sometimes? Yeah. Will you have to simplify radicals? Yeah. but it's really, really straightforward. Okay. Let's try another one.
Wait, so that's all you have to write?
Yeah.
You don't have to find the angle?
Not yet. Don't know how to do that yet.
Well, can't you do the, like, the law of cosines and then find that angle and then subtract 360 from
Let's write triangles. I'll just use inverse sine and hit the button.
Oh,
Where's your glasses?
at home. I get more and more blind every day.
You don't wear your glasses.
No, they say that if you don't wear your glasses that your vision shouldn't get worse because you're like constantly practicing. It's true. No, because if you always wear your glasses, then it's like your eyes never have to do any work. So then they just get worse.
I still have to see.
No.
It's clearly. All right, -12, -15. I'm sorry, but that doesn't
What'd
make,
you say?
that makes absolutely no sense.
It's
I-
true.
No, no, I'm gonna,
Just wear your glasses.
I would suggest just wearing your glasses.
No, it's true. I'm positive.
-12, -15, which quadrant will this wind itself into? Third quadrant.
Okay, let's all laugh more. I see how it is. I'm serious. It's the true rating.
Where'd you hear this?
The eye doctor.
I highly doubt that.
My mom heard it from the eye doctor.
Mom.
My mom told me.
It's like the telephone.
How does that not make any sense? Because the more you practice trying to see far without your glasses, the more that like you'll get like better at it.
No.
Yes.
You're just straining your eyes and making them worse.
No, you're not.
Yes, you are.
No, you're not.
Anyway, so let's use Pythagorean theorem to figure out what the radius is. 12 squared plus 15 squared is our radius squared. Is there any reason as to why I did not bother with putting the negatives there? They just cancel out anyway, and if you put that in your calculator as -12 squared, you're going to be wrong because it'll say -144. So I just skipped. So let's see, 12 squared is 144, 15 is 225, so it'd be 169, no, 369?
Wearing glasses too often will weaken their eyesight, and they will increasingly rely on them more often than firstborn.
Okay, but not wearing them doesn't make your eyesight better.
I just said that it makes your eyesight worse to like wear them. Like
You said
No, you
practicing
said that
without
you training
glasses
your
makes them
eyes
better.
to make them better. We have it on recording, so we can play that and show you that you're just wrong. So, what's your radius when you go into the simplified radical form?
well,
Whoa, what is this decimal thing you speak of? It's not 19.2. Remember how to check it in these calculators if you are allowed to use one? What was it, 369? Oh. $341, okay. So now as you go through all those, you just have to be careful with that root 41 in your denominators, which means you just have to rationalize. Excuse me. I'm going to try my best to start saying cosine before I say sine, because cosine goes with the x. Sine goes with the y. So this is gonna be x over r, so that's negative 12 over 3 root 41, which means you have to simplify that out. Now, first thing you have to do is just really easy with the negative 12 and the 3, that just becomes negative 4. But then what do you do with the root 41? Yeah, you guys know how to rationalize, correct? So you're going to get for this. For this one, you're going to get negative 4 root 41 over 41. We okay with that? Sine was negative 15 over the 3 root 41. So you get negative 5 root 41 over 41. And then the tangent's just going to be negative 15 over negative 12, opposite over adjacent. And that's a positive, what was that, 5/4. And then just flip everything. So the inverse of cosine is secant. Well, if I go to my original one that wasn't rationalized, it's easier to work with. So all I have to do is flip this. It becomes 3 root 41 over the negative 12. So that's just root 41 over negative 4. Can I put the negative anywhere in that case? Yeah, doesn't matter. Okay. Same thing with the next one. The inverse of sine is cosecant. So you have root 41 over negative 5, and then cotangent 4/5.
Why did you write cosine first?
Because it goes with the x values. Cosine is x over r. Sine is y over r. If you start thinking about your ordered pairs go x, y. Might as well be the x values first.
Okay.
So as we get into this ever a little bit more and more and more, what we're going to see is, is this. Let me do this first.
It's fine, I understand.
No. It's not just for, it's not just all about you. Now go back and think about it. Since cosine values are your x values, is the x divided by r, was your radius ever negative? Can the radius ever be negative? Because you're squaring it for Pythagorean theorem. Since you square everything through, your radius will always be positive. So no matter what happens then is you're just looking at your ordered pairs in terms of, well, they're both positive here. Cosine is positive in the first quadrant. Sine is positive. Cosine's negative. Sine's positive. Cosine's negative. Sine's negative. Cosine. Sine. Tangent. Tangent is y over x. So if y and x are both positive in the first quadrant, what's a positive divided by a positive? Positive. So first quadrant tangent is positive. Second quadrant, what's it going to be? Negative. Third quadrant, positive. And last quadrant, negative. And the reason that happens is because of your signs, your SIGN, the signs, positives and negatives. Since your ordered pairs, if your ordered pairs are you know how your x and y values are moved in the a regular old grid, you will then know the signs, the positive negatives of your trig functions because of that, because of how things get placed. Okay. The signs for the reciprocal functions match the same thing as the standard trig functions. So if cosine's positive, secant's positive. If cosecant's negative, sine would be negative, and so on. Does that make sense? Now, we kind of did a little bit of this right in the very first day. I think I gave you guys, hey, sine of theta is 5/7. Figure out all the rest of it. It's kind of the same idea. That 5/7 was actually an ordered pair. It was the y value and the radius. You were able to figure everything else out from that. So, let's try another one. -1 and 1. I go -1 and 1. What quadrant does that put me in? 2, good. What's your radius? √2, very good. It's √2. Remember 1, 1, √2?
Is it?
Yeah, that's a 45-90 triangle. Right. So if you go through the whole thing, you go cosine. Well, will cosine be positive or negative in the second quadrant? It's negative, because what's your x value? It's negative. What's up, Trap? You said about
I didn't
that.
see the negative sign.
Oh. And then your reciprocal functions are just flipping those fractions. So you get -√2, positive √2, and -1. Again, because what we're doing is we're using this as our theta because that's the reference angle. I'm a really good singer. If I would have sent in a tape like that, their ears would have exploded. Do I have to write out the reciprocals? Are you guys okay with that? Let's look at something called the quadrantals. That's many words. Is it AL or EL? AL. The quadrantal angles. They're the opening act for the band. Quadrantal angles. I hear they're really cute. I'm an idiot. Quadrantals. It's the angles on the axes. Your quadrantal angles are the angles on the axis. Now, when we did this, when we started marking up that unit circle, we said that this was at 0, 180, came back around to 360, half of 180 was 90, in between here you added that 90 to come back down, we were at 270. Now, excuse me, what happens when you're on the quadrantals? I want you to think of this distance from here to here. You're moved on which axis? the x-axis. Okay, we okay with that? Your x-axis is what you moved. Now, if this is some ordered pair, what's my y value going to be at that value? 0. Okay, it's going to be 0. My x value, though, my x value is just x. It can be anything. Because if you think about it, isn't that value of x also going to be the exact same thing as your radius? Because the radius would have to come out to that point. So the value of x is always going to equal your radius here. Same thing as you come up here, your y value is going to equal the radius. The negative x equals the radius, and so on and so on. Okay? That's why what we do, if you, no matter what value you place that at, you're able to figure out your values of sine and cosine and whatnot on the quadrantals just by the ordered pairs. Okay? Just by the ordered pairs. So in this case, it's going to be whatever your value of x is, whatever your value of x is. It doesn't matter, because the x and the r value are the same. As you move up here, what became 0? X became 0. Here it was negative x and 0. Here it's 0 and negative y. The quadrantal angles are the ones that we never bothered with in terms of SOHCAHTOA. Remember how we never worried about sine of 90? Anything like that? Because when you start thinking about it, at the sine of 90, sine of a value in a right triangle, sine is opposite over hypotenuse. Do you agree? Well, what's your opposite at 90 degrees? It's your hypotenuse. What's hypotenuse divided by hypotenuse? 1. So what's the sine of 90? 1. So no matter what, this value here is always going to be 1. So your ordered pairs become 0, 1. What do you think it's going to be down here at 270? 0, negative 1. No matter what, because the values of x, because y and r are the same at that point. Okay. Excuse me. So what do you think I'm going to change on the x values here? Put them at 1. Because your radius can always be simplified out to being 1. Because no matter what, if they're the same value, if it's 7, your radius is 7. What's 7 divided by 7? 1. So your quadrantals are always placed out. Think of it as 1, 0, 0, 1, negative 1, 0, 0, negative 1. As you go all the way around that circle. Because that radius will never change. Because x divided by r is 1. Because they're the same number. Right? So it always simplifies out. So that means you can list out all of your, what do you call them? The sine, cosine, and tangents at 0. If I do sine, cosine, and tangents at 0. Oh, so we start with cosine first. Cosine is 0. Well, at 0, the ordered pair was 1 and 0, and you had a radius of 1. So what's 1 divided by 1? 1. So cosine at 0 is 1. The sine of 0, that's 0 over 1. Tangent at 0, 0 divided by 1. Reciprocals. The secant of 0, well, what's the reciprocal of 1? 1. The cosecant of 0. Well, what's the reciprocal of 0? Undefined, good. And then again. All of these values, how they, as you work yourself around the circle, as we start to get into this more and more, how the oscillation between the zeros and the ones and all that, how they change their signs, the SIGN, is going to show why sine curves oscillate back and forth. It's all because as you go around the ordered pairs, you're changing your signs, your SIGNs as they go. It's crazy how it works. It's pretty kind of neat. Okay? What's wrong with you? Down today. I know. So let's do the 6 functions at 180. What's the ordered pair at 180? Negative 1 and 0. If my ordered pair is at negative 1 and 0, what's your x value at 180? Negative 1. What's the y value at 180? Are you guys starting to catch on that the ordered pairs, your x and y's, those are your cosines and your sines? That's how everything works itself out. Tangent, then remember, is y over x. What's 0 divided by negative 1? 0. And then you just do the reciprocals. Will any of this change if they put quadrantals in terms of radians? No, not at all. It doesn't change whatsoever if you start putting those in like that either. So if I say, what would it be, 3? If I say find the 6 functions at 7 pi over 2. Find the 6 functions at 7 pi over 2. First thing we have to do is figure out where 7 pi over 2 goes. Now, I know that you were saying that you don't like to do the radian thing. I want you to see how fast it actually is to plot it. 2 goes into 7 how many times? 3. How many are left over? 3 and 1/2. So this is 3 and 1/2 pi. So what we do is we count. 1 little, 2 little, 3 little pi. Now, half. Think of this as a whole going all the way across. Half is right here. What's the ordered pair? There.
Why'd you go like the y?
It doesn't matter. I just put it. Does it matter where? Negative 1, yeah. So it's 0, negative 1. All you have to do is spin it to win it. And it gets you to the spot you have to be. And that was the idea of by showing you guys how you're able to spin stuff around. If you land on a quadrantal, no matter what, you're always going to know your ordered pairs. Because it's either a 1, a 0, or a negative 1. You just have to know where you go. Okay? Yeah, try.
I don't get how, like, where you get the 1.
Okay. Do you agree that...
Wait, wouldn't you go around 3 times?
No, remember this is 0, 1 pi, 2 pi. Every 180 is 1 pi. Do you agree that if I'm at this value right here, what's my value of x for that ordered pair? 0. if I'm talking about this in terms of a radius, this radius and the y value are the same. They're the same at this point because they went the same distance. Okay? So that means that only thing that happened was I moved down, so y is negative. The reason that they're the same is you go through it, no matter what your r value is, if you start going through it, if the two numbers are the same, if you think about the sine is always opposite over hypotenuse. If the opposite and the hypotenuse are the same number, all you have to do is, when you divide two numbers that are the same, what do you always get? 1. It's negative because y values are negative going down. That's all.
Well, why do we use it?
Why do we use it? Why we use 1?
Why can't we, like, wouldn't there be like a, not like more efficient way, but wouldn't there be like a better way to like figure out like?
That this is the most efficient, because let's say for example this was 1, 2, 3, 4, 5, 6. Let's say it's negative 6. Okay. If I go through and use it to figure out the Pythagorean theorem, remember your r squared is going to equal x squared plus y squared. So r squared is 0 squared plus negative 6 squared. R squared is 36. R is 6. It's the same thing. When you go through that then, as you simplify it through, the sine is y over r. So in this case it would be negative 6 over 6, which simplifies out to be negative 1. And that wouldn't change if that was a 6, a 6, a negative 6, a negative 60, negative 16, negative 443. Because what happens is when you put the fraction together, it always simplifies to be 1.
So you're using like 1 as like a variable?
No, I'm not using it as a variable, I'm using it as 1. Because no matter what, what's 8 divided by 8?
But like you don't know, like, isn't it kind of like?
What's 8 divided by 8?
1.
1, yes you do.
Yeah. I mean, like, but like, if you're finding like the sine, then you would have to solve for that. Wouldn't you?
What do you mean solve for it?
Like, if you just give us like the order pair 0 and negative 1, then you'd have to like, would you ever like make a solve for like how long the radius is?
Well, the radius for these would always simplify out to be 1 when you're on the quadrangle.
Yeah. So like,
That's just,
not the actual radius.
that is the radius.
But that's
Because
the
it-
sine.
No. You're overthinking this. Because remember, no matter what, sine of any angle is y over r. If those two numbers are the same, it would always equal 1. That's why, whenever you're at 90 or 270, you're at pi or 3 pi over 2, your x value is always 0. No matter how many you count up and or down. Since these two values are the same, when you divide it out, you always get 1 or negative 1. That's how it always is going to work. Because when you have right triangle, if I'm at 90 degrees, what's my opposite? It's my hypotenuse. What's hypotenuse divided by hypotenuse? If this is 5, what's 5 divided by 5? It's always going to be 1. Okay?
That's still like, if
When we start to put in the other angles, it'll help. It'll help.
then if the both values are the same, then how can you get a negative?
It's just position. Negative is just
Oh.
distance. It's just which way did it go? Was it above it or below it? Because as you go up, you're positive. As you go down, you're negative. Same deal here. That's positive. That's negative. Because you went left. That's it. Okay, that's all it is. We'll stop there. What I would like you to do what I'd I'd like you to do is on, this is what, 13.3. Do those. Because the rest of it we haven't been able to get through. Oh, wait. And then, sorry. I want you to practice through 44. The last 8 are just finding reference angles. You know how to do that. Spin it and just figure out how far they are off the x-axis, just to get us prepared for tomorrow. So the 26 through 36 is today's stuff. The 37 through 44 is just find reference angles. You know how to find a reference angle. I just want you guys to practice, because we haven't done it in a while. I want you to practice that, because once we figure out how to find the reference angles, tomorrow's going to make it so much easier. Okay?
Mm-hmm.